Morning. Today we are correcting CO23. Yesterday we talked about the different ways we can find the greatest common factor. One way was that prime factorization. We did those three in class together. The next way was listing our different factor buddies. Please stop talking. Listing our different factor buddies. We did the first one together. And then I said list the factor buddies for the next two. So we should see lots of factors listed for 24. 1, 2, 3, 4, 6, 8, 12, and 24. Then for 36, we had 1, 2, 3, 4, 6, 9, 12, 18, and 36. The biggest factor that they both shared was 12. 8, 16, and 48. I see the factors 1, 2, 4, and 8 for 8. For the 16, we have 1, 2, 4, 8, and 16. And for 48, we had 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. You need to make sure you are listing all of those factors. As I was walking around, I noticed some of us did not list them all. If you miss some factors that you're listing, there's a good chance you could miss what the greatest common factor is. So if we look at it, the biggest number they all shared is the 8. So the greatest common factor for those three numbers is 8. Then we talked about our table method. And on our homework page, we had to do whichever method we wanted. No matter which way we do it, we should come up with the same greatest common factor. So for 18 and 45, the greatest common factor is 9. For 24 and 54, the greatest common factor is 6. For 60 and 12, the greatest common factor is 12. For 48 and 32, the greatest common factor is 16. For 18, 30, 42, the greatest common factor is 6. And for 15, 25, and 40, the greatest common factor is 5. Which of these can I help us go through whatever method you use to see how we should have found that greatest common factor? Callie.
For me, it was 18, 30, and 42.
Which method did you use?
I used the Christmas tree.
Okay, the prime factorization, making our tree. So for the 18, I broke mine down to 2 and 9. 2 is a prime, so it stays all the way down to the bottom. 9 can be broken into 3 times 3. So my prime factorization is 2 times 3 times 3. Did you get that for the 18? What did you get?
I did the different ways.
So which factor pair did you start with?
I started with 4.
Oh.
Oh, wait. No.
That's where you went wrong. 6 times 4 is 24. So we used the wrong factor pair to start with. So that's going to give us a different factorization, and it's going to mess it up. Anybody else not sure why they got a different greatest common factor? So we all got, yep, Madison?
So I thought that I was supposed to get, for some reason, when we used to, find, the least common denominator, I was doing that because that was going through my head when I got home. So I found the least common denominator for every single one instead of finding the greatest common denominator for every single one.
Got it.
So, for number, for 1825, I got 3. And for, this one, I got 6. And then, for the 12, I got 2.
Sure. So we got to switch our gears.
Yeah.
We don't want that smallest common denominator that we want to use when we're doing common denominators with those fractions. We're moving out of that.
Yeah.
Now we want the greatest common factor. So when we see that G, that's our clue. We got to look for the biggest number. It's easy to fall back into a different way of doing stuff. I get it, but we want to keep practicing that. I highly suggest you go back and redo everything to make sure that you're changing the brain, right? You got to change the way that you're thinking so we can get that greatest common factor. Callie.
I actually was a different equation, but I did
6, and then I didn't do 2 and 3. I did 3 and 3.
And that is super, super, super common, friends. Every year I have multiple people that when we break up the 6, we forget that it is 2 times 3. Oh, so many people know that 4 gets broken up into 2 and 2, and 2 plus 2 is 4. So their brain just automatically jumps to 6 is 3 plus 3. And we want to always remember to look at the multiplication. We are multiplying here, not adding. We're multiplying with that 4, not adding. Super common mistake that people make. 6 is 2 times 3. Ava, please stop. Any other ones that you want me to go over on this top part? Kelly, do you have one? Okay, so let's look at our word problem. Whenever you're given a word problem that includes the phrases identical and all of the items will be using that greatest common factor. So, Mr. Schultz is making lunch for his children. He has 8 sandwiches. Holy cow, his children are hungry. He only has 4 kids. Whew, they're going to eat 2 sandwiches each. He has 8 sandwiches, 20 beef jerkies, and 12 strawberries, and 44 gushers. How many identical lunches can he make using all of the items? So I told us we needed to find that greatest common factor of all 4 numbers, 8, 20, 12, and 44. So it comes down to 2 times 2 are those prime factors that they all share. So he can make 4 identical lunches. And just for funsies, how much of each item would he have? So I said your clue was to find the factor buddy. So if he has 8 sandwiches and he's making 4 lunches, 4 times what equals 8? 4 times 2. So he's going to have 2 sandwiches in each lunch. There are 4 lunches. 2 sandwiches in each lunch uses up all 8 sandwiches. He has 20 beef jerkies, and there are 4 lunches. 4 times 5 equals that 20. So there's 5 beef jerkies in each lunch. Then he has 12 strawberries. So 4 times 3 equals 12. Everybody only gets 3 strawberries. I would rather have 5 strawberries and only 3 beef jerkies. He's given lots of beef jerkies away. And there are 44 gushers, 4 lunches, so 4 times 11 equals 44. So every lunch gets 11 gushers. Madison.
So I did that. I did all those steps, and then I also put how many items would be at each of lunch. So I got 21 items, 11 plus 3 plus 5 plus 2 equals 21.
So with 2 sandwiches, 5 beef jerkies, 3 strawberries, and 11 gushers, there are how many? 21 items in each lunch. Oh my goodness. That's a lot of stuff to have for lunch. Oof. His poor little kids are going to get tummy aches. Oh my. All right. Any questions on that problem? You will see word problems like that on the test. You need to know that we're doing greatest common factor and that we have to find the factor buddies. Keep that in mind. Now, time for review. What is the divisibility rule for 3? The sum of the digits is divisible by 3. You just had to go back to that objective and write it out. What is the divisibility rule for 5? Ends in a 5 or a 0. What is the divisibility rule for 6? It is divisible by both 2 and 3. Is 45 composite or prime? It is composite because we know it's divisible by 5. It's divisible by 9. We need to know it's divisible by 3. It's divisible by a number. Is 51 prime or composite? It is composite. It is divisible by 3. 5 plus 1 is 6. 6 is divisible by 3. Is 29 prime or composite? It is prime. We cannot divide it by anything else. What is the prime factorization of 42? It is 2 times 3 times 7. No other answer. 2 times 3 times 7. That is the answer. Madison.
Wait, no, I wasn't.
And what is the prime factorization of 16? 2 times 2 times 3 times 5. That is the prime factorization of 60. Any questions on the review? If you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day.